Dear students, in this video, I will tell you some more examples of remainder and factor theorem. In remainder and factor theorem, there consists the types of questions, different questions. The first, I told in the previous video that you have to find the remainder, the value of the remainder without actual division. Here I will tell you about how to show that a given expression means polynomial is a factor of the another polynomial. I told you if a number divides completely the other number, then that number is known as the factor. In this case also, if we divide this by this number 2x minus 3 and remainder comes 0, it means this is a factor. This is the property of the factor. Show that 2x minus 3 is a factor of 2x cube plus 3x square minus 5x minus 6 and hence factorize. Thereafter you have to factorize this one, because if we show that this is a factor so it means there are two more factors in this expression, polynomial. How the two more factors? Only three factors. The factors, number of factors depends on the highest power of the x given in the polynomial. Here the highest power of x is 3, therefore there should be the three factors. And if it is a factor, it means the two more factors you have to find. That is why it is given the and hence factorize completely. So now let the question this one, and first of all you have to let this expression and this expression as fx and gx. Fx means that you have to divide and gx means the divisor, 2x minus 3. According to the remainder theorem, gx is equal to 0. So 2x minus 3 is equal to 0. So x is equal to 3 by 2. If x is equal to 3 by 2, you put in the equation 1, that is the remainder. So f3 by 2 in place of x, 3 by 2. f3 by 2 is remainder. This you have to write in every question if you are doing like this. f3 by 2 is remainder. It means when you put the value of x in this equation, after solving you will get the remainder. Now we are putting the value x is equal to 3 by 2 in this equation. 2 3 by 2 whole cube plus 3 by 2 whole square minus 5 3 by 2 and minus 6. Now we have to solve. f3 by 2 is equal to 2 into 27 by 8 plus 3 into 9 by 4 minus 15 by 2 minus 6. Take LCM. LCM is 8 obviously. This 27 2s are 54. Multiply by 2. So 3 2s are 6, 9, 54. Minus 60 and minus 48, and this is equal to 108 or minus 108. You can see both are and then this will be 0. If it comes 0, I told you previously that if the remainder comes 0, it means the given divisor is a factor. Therefore 2x minus 3 is a factor of fx by factor theorem. After proving that this comes 0, you can write here by factor theorem. Here that in the first step you have written the by remainder theorem, because you are finding the remainder, and if remainder is 0, then at last you can write this is proved by the factor theorem. Now, how to factorize completely the given expression? Hence, factorize. What is the meaning of the hence? Hence means you have to use the first part of the question, means 2x minus 3 if you have shown it is a factor, then that factor you will take as the rest of the part, means for the second part. This is the meaning of hence. If you, so how to factorize fx? We factorize by the long division method. Directly divide this 2x cube plus 3x square minus 5x minus 6. That's why I prepared one more video for the long division. You can see in my channel. 2x minus 3. How to divide this one by the 2x minus 3? If it is 2x and it is 2x cube, by which number you multiply this 2x to get the first term as 2x cube? Obviously by x square. If you multiply this by x square, you will get 2x cube. So multiply by x square this. So the first term 2x cube, x square into minus 3x square, and then subtract. This is cancelled. 6x square minus 5x. Then again, by which number you multiply this 2x to get 6x square. So multiply this 2x by 3x. So plus 3x, 6x square, and 3x into minus 3, 9x. Whole plus and minus 9, plus 9 minus 5, that is 4x minus 6. Then again, which number you multiply to this 2x to get the 4x by 2. So plus 2, 4x and minus 6. Now you can see this is the remainder, and this is not by the remainder theorem, this is by actual division. But when you do the question in the exam, then you have to apply that method by remainder theorem, not this method. This method only when you factorize the hence factorize, then you apply this method. But this is not factorize completely, because factorize completely means we have the 3 factor, but here the only the 1 2x minus 3, and this is also the factor, because when you divide this one by this, you will get 0 again. You can factorize this part also by the simple factorization. So now to factorize x square plus 3x plus 2, we have x square plus 2x plus x plus 2. Simple factorization as you have read in class 9. X is common, x plus 2 and plus 1 is common, x plus 2. So x plus 2 and x plus 1. Now you can see this is the one factor. Now these are the 2 more factors. So factors of fx. Factors of fx are, you will write all the 3 factors of this, that is 2x minus 3, x plus 2 and x plus 1. This is the answer. So by this way you can show that this is the factor and you can factorize completely. Now second example of this, if in a question given the constants and you have to find constants, then how to find the constants? There is a question. X cube plus ax square plus bx plus 6 has x minus 2 as a factor and leaves the remainder 3 when divided by x minus 3. Find A and B. So how to find the A and B? If x cube plus ax square has x minus 2 as a factor, means this is given already, x minus 2 is the factor of this expression. But when we divide by x minus 3, then it leaves the remainder 3. In place of the 0, it leaves the remainder 3. So what is the method to solve this type of question? First you write, let fx is equal to x cube plus ax square plus bx and plus 6, and gx is equal to g1x because there are the two expression, two divisor, and g2x is equal to x minus 3. This is the equation 1. By remainder theorem, same procedure you have to apply. By remainder theorem, let g1x is equal to 0, therefore x minus 2 is equal to 0, x is equal to 2. It means f2 is remainder, f2 is remainder, and put the value of x is equal to 2 in the equation number 1. Now we put x is equal to 2 in equation 1. So f2 is equal to 2 cube a 2 square plus b 2 plus 6 8 4a plus 2b and plus 6. Then one more line you can write as 14 plus 4a plus 2b f2. In the question it is given that x minus 2 is a factor. It means the remainder will be 0. Therefore, because x minus 2 is a factor, so 14 plus 4a plus 2b is equal to 0, and then divides by 2 also. So you will get 7 plus 2a plus b is equal to 0, or 2a plus b is equal to minus 7. This is the equation number 2. In a and b, you have the one equation. It means one more equation you will get when you divide by x minus 3. Now, x minus 3 is equal to 0 means g2x. X minus 3 is equal to 0, so x is equal to 3. Therefore, f3 is remainder. And then again we put the value of x is equal to 3 in the same equation number 1, and we will get the one more equation. Now we put x is equal to 3 in equation 1. So f3 is equal to x cube plus a x square plus b x and plus 6. Then this is equal to 27 plus 9a and plus 3b plus 6. But in this leaves the remainder 3. Leaves the remainder 3 means we have to write this f3 is equal to 3 because it leaves the remainder 3. This is not a factor. If it is a factor, then take is equal to 0. Now, according to question, f3 is equal to 3. So 33 plus 9a plus 3b is equal to 3. So 9a plus 3b is equal to minus 30. R divide by 3. So 3a plus b is equal to minus 10. Equation number 3. Now solve simultaneously equation 3 and equation 2. So 2a plus b is equal to minus 7 and 3a plus b is equal to minus 10. Simplify, subtract. Minus a is equal to 7, or 3 is equal, a is equal to minus 3, and then b is equal to 2 into minus 3 plus b is equal to minus 7. So b is equal to minus 7 plus 6 means minus 1. So these are the values of a and b. If in the question asking one more part, by using these values of a and b factorize completely, then you will put a and b in the equation 1, means in fx, and then factorize by the previous method which I have done in the previous question. Thank you.